Hello everyone, I am your friend Shadab Imam and we are continuing our lecture series on operations research, and today we are going to see another variation in the network problem. So please watch this video till the end, and if you are new to the channel, please subscribe the channel and don't forget to hit the bell icon. So let us quickly see what the question is. So the problem here says that a project schedule has the following characteristics. So this table has been given activity and time, and we need to construct the network, find earliest and latest times for each event, find the critical path. Now in this particular problem we can see that there is no precedence given to draw the network. That is because the activities are given in the form of node. As we can see here, first activity is 1 2, that means from node 1 to node 2. So for this type of problem it is very easy to draw network diagram because there is no need of a dummy activity, so we do not need to worry about the precedence in the network. So it is quite easy compared to the one where the activities are shown specifically rather than in the event form. So let us start constructing the network. So first activity 1 to 2 is having the time 4. So we'll first write the activities. This is 1, this is activity 2, and this is 1 3, this is 1 2 3. This is having the time 4 weeks, this is having time 1 week. Similarly here activity 2 4, that means 2 to 4. So I'm just drawing it here, 2 to 4, and this also has the time of 1 week. Now 3 to 4, so this is activity 3 to 4, and this also has a time of 1 week. Activity 3 to 5, so we'll see here activity 3 to 5, this is activity 5, and this is having a time of 6 weeks. Now activity 4 to 9, let us draw it somewhere here. So this is activity 4 to 9, and this is having the time duration of 5 weeks. Now activity 5 to 6, so this is activity 5 and let this be activity 6. So this is activity 5 6, this is having a time of 4 weeks. Now activity 5 7, so let us draw it here, activity 5 7, this is 7, and this is having a time of 8 weeks. Now 6 8, activity 6 8, so we'll draw 6 to 8, this is 8, and this is having time of 1 week. Similarly 7 to 8, so this is 7 8, so we'll draw 7 to 8, and this is having a time of 2 weeks. Similarly 8 to 10, so we'll draw here 8 to 10, let this be node 10. So this is activity 8 to 10, and this is having a time of 5 weeks. And the last activity 9 to 10, so this is 9, this is 10, so 9 to 10, this is the activity 9 10, and this is having the time of 7 weeks. So we have drawn the network diagram here, and so the first part we have completed, and as we can see that there is no problem whatsoever in drawing this network whenever it is given in the form of event, as we do not need to consider dummy activity for this because no precedence has been given. Now let us start calculating the earliest and the latest times for each event. So we know that first we will calculate the earliest time. Now to calculate the earliest time, we need to understand that this is calculated by using forward pass method, and in this particular method we will select the maximum value. If you are not getting this, it will be clear very shortly. And the latest values, the latest time is calculated by using backward pass, and in this particular method we will select the minimum value. So we need to remember this to calculate the earliest and latest time. So first we will calculate the earliest time. So we can see here earliest time is calculated by forward pass method. So in forward pass method we will start calculating the time from first node, or we can say starting node, and as we move ahead, suppose if we are moving from node 1 to node 2 and there is only one activity coming at node 2, then we will add this time duration of this activity and we will go ahead. And if there are more than one activity coming at particular node, suppose at this particular node we can see that two activities are coming, in this particular case we will select the maximum value. So whichever value is maximum, we will select that particular value as the earliest value. So let us start calculating. Initially E1 is equal to 0. Now moving on to 2, we can see that only one arrow is coming here, so we can add 0 plus 4 is 4, so the value of E2 is coming as 4. Now moving on to 3, we can see that only single arrow is coming here, so this is 0 plus 1 is 1, so E3 is equal to 1. Now moving on to 4, E4 is equal to, now at this particular node we can see that two arrows are coming, so we will consider both the values. So this is 4 plus 1 5, this is 1 plus 1 2. So as we have discussed, now we will select the maximum value, so we will select the value 5 here. Now moving on to node 5, E5, that is the earliest value at this node, is equal to, as we can see that only single arrow is coming, so this is 1 plus 6 is equal to 7, this is equal to 7. Now moving on to node 6, node 6 we can see that there is only single arrow coming, so we will add the activities. This is 7, this is 4, so E6 is equal to 11, 7 plus 4 11. Now moving on to 7th node, we can see that only a single arrow is coming here, so this is 7 plus 8, 7 plus 8 is 15, so this E7 is equal to 15. Now moving on to the 8th node, we can see here E8 is equal to, now at this particular node there are two arrows are coming, so for this we will consider the both the values. This is 11 plus 1 12, this is 15 plus 2 17, so we will select the maximum value here, so E8 will be 17. Now moving on to node 9, at node 9 we can see that only a single arrow is coming, so this will be 5 plus 5 10, so E9 is equal to 10. Now moving on to the final node E10, we can see here that two arrows are coming, so let us see what are the values. This is 10 plus 7 17, here it is 17 plus 5 22, so again we will take the maximum value here, so this will be 22. So from this we can find out that the project completion time, is equal to 22 weeks. Now As we have calculated the earliest values at each node, now we are going to calculate the latest value. Now in order to calculate the latest time, we will use the backward pass method. In backward pass method, we will start from the finishing node and we will consider this completion time as the initial value. So L10 is assumed as 22, same as this, and as we move ahead we will subtract this. Suppose if we are going from 10 to 8, we can see that from 8 there is only a single outgoing arrow. So for this we are going to subtract this from the latest value. And in case where more than one arrow or more than one outgoing arrow is there, as suppose node 5, from node 5 we can see that there are two outgoing arrows. So we will select we will consider both these values and then we will select the minimum value here. So it is easy to remember now that for forward pass we will select the maximum value, for backward pass we will select the minimum value, and here in calculating the latest values we will select the minimum value. So let us start calculating. So let's move from 10 to 9. We can see that only a single outgoing arrow is there for 9. So we will simply subtract this. This is 22. 22 minus 7 is 15. So L9 is equal to 15. Now let us calculate at node 8. So from 8 we can see there is only a single outgoing arrow. So again we are going to subtract this value directly. So L10 is 22, 22 minus 5 is 17. So L8 is equal to 17. Similarly, moving on to node 7, we can see that from 7 also there is a single outgoing arrow. So again we are going to subtract this value from this latest time. So this is 17, 17 minus 2 is 15. So L7 is coming as 15. Now moving on to 6th node. As we can see from here, there is a single outgoing arrow. So again we are going to subtract this from this latest value. So this is 17. 17 minus 1 is 16. So L6 is equal to 16. Now moving on to node 5, we can see here that there are two outgoing arrows. So we will consider both the outgoing arrows. So let us see what are the values. This will be 16 minus 4. 16 minus 4 is 12, and for this it is 15 minus 8. 15 minus 8 is 7. So as we have discussed, for latest time we will select the minimum value. So we will select the minimum value among these two. So this is coming as 12 and this is coming as 7. So we will take the value 7 and L5 is equal to 7. Now let us see the node 4. At node 4 we have a single outgoing activity. So we will just subtract this value from this latest value, that is 15 minus 5 is 10. So L4 is coming as 10. Now moving on to node 3. From node 3 there are two outgoing arrows. So let us see what are the values here. This is 10. 10 minus 1 is 9 and this is 7. 7 minus 6 is 1. So we will take the minimum value here again. So L3 is equal to 1. Now moving on to node 2, there is a single outgoing arrow here. So again we are going to subtract this value. So this is 10. 10 minus 1 is 9. So L2 is equal to 9. Now moving on to L1 or node 1. So L1 is coming as 0 because this is 1. 1 minus 1 is 0. This is 9 minus 4 is 5. So we will select the minimum value. So now we have calculated all the earliest and the latest value at each node. So we have completed the second point also. Now in order to find out the critical path, we need to say at which node or at how many nodes the value of E and L are equal. That is the earliest and the latest time is same. So we can see that at node 1 it is same, at node 2 it is different, at node 3 it is same, So at node 4 it is different, at node 5 it is same, at node 6 it is different, at node 7 it is same, at node 8 it is same, at node 9 it is different, and at node 10 is same. So the nodes from where the values of E and L are same, we are going to draw another line which will show that this is your required critical path. So let us draw lines here. So as we can see here, this is the critical path 1, 3, 5, 7, 8 and 10. So the critical path is coming as 1, 3, 5, 7, 8 and 10, and this constitutes the total or the maximum time as 22 weeks, which is the project completion time. So this is 22 weeks. So finally we have completed the third part also. So as we have seen that it is quite easy to construct a network diagram whenever it has been given in the node form. Activities are given in the form of node, because there is no precedence to follow to see and to use the dummy activity. So I hope you like this lecture. Please share the lecture and have a nice day. Thank you.